Assalamu alaikum. Bismillahirrahmanirrahim. We are discussing Juniper certification program, and that is specialist level JNCIS. Our course is service provider routing and switching JNCIS-SP. That have three modules. One is routing, second one is switching, and third one is MPLS. Okay. We have already done routing section, switching section. Now we are just starting MPLS fundamentals. Okay. Last class we discussed course introduction. Today we discuss MPLS introduction. So you can consider this is the first class regarding MPLS. So it's a fresh start of MPLS. I think you will enjoy MPLS, our entire MPLS session. So let's start MPLS introduction modules. So let's start our course slide. Okay. This is basically it's a introduction. So it's most of the topic is theoretical. So next we'll get configuration there. When we get configuration part, then I show you in our lab. Okay, so this is today's topic is MPLS introduction. So I think it's completely theoretical, but this understanding is very much important. You will not, if you not understand the theoretical concept, then it will difficult to deploy MPLS in your organization or in your lab device. Okay, so MPLS introduction that have five sections actually. First is routing and forwarding tables. This is the just you can say review. You can say review of some concept that is discussed in routing and routing section. Basically, that is routing and forwarding tables, BGP next hops, original, and the actual MPLS section is the section 3. Original historical motivation for MPLS, this one, and modern use cases for MPLS, that is part 4, that is section 4 and section 5. So let's start. Refresher, routing, and forwarding tables. So in this section, we will discuss about routing and forwarding tables. We already know this one. What is routing table and what is the forwarding table? The routing table is just you have multiple paths to go towards a specific destination. So if you mm, think just routing, it can be IGP or it can be BGP. They have multiple paths, but only one will be the best. Only one path will be the best. So that best path will go to the forwarding tables. That is the concept of routing and forwarding tables. That means forwarding tables have best path, and routing table have best and valid path, both. So that's the difference. So key concept we have learned so far. This is the terminology or acronyms like MPLS, multi-protocol level switching, PDU protocol, PDU, LSP, SD1, SSIC, DFZ. This terminology will be discussed in coming slides. Okay, so welcome to the world of MPLS. Welcome to the world of MPLS. So MPLS is a protocol that powers almost every internet service provider in the world. So this technology has some power. This technology has some solution you can use. that can enhance your network, and you can say that can be a financial benefit. You can sell VPN, L2 VPN, L3 VPN, and you can take money from for giving the solution. Okay. So that's why this statement is here. MPLS is protocol that powers almost every internet service provider in the world. What is an MPLS label? Basically, MPLS backend communication is happened through label, MPLS label. You can say it's a signaling protocol about the MPLS. What advantage do labels bring? What advantage do labels bring? Labels basically bring their faster. If you compare with routing protocol or routing lookup, label switching is more faster than routing lookup. So this is the main benefit of MPLS. And another benefit you can tell, you can add traffic engineering. You can utilize underutilized path. Okay, so and some solution which is which problem is coming from or which requirement is coming from your customer. How do you labels? How are they generated and advertised? How to generate it and advertise? You can generate it statically, or it can be generated and advertised dynamically. If you think label will be generated in dynamically, so you have to use the protocol. You have to use like LDP, like RSPP, like segment routing. Okay. How do and third point is how do labels create forwarding options by following the base path. Create forwarding options by following the base path. Why is MPLS so powerful? And why is it often used alongside BGP? There is many questions. Yeah, there is many questions. Why we use MPLS? What is the advantage? Okay, why is it powerful? Why all service providers choose this one? So many person here. I will give you the correct answer. Enter the journey and enter the MPLS journey. Okay. Routing tables. This is a traditional routing table. That is this routing table for IPv4. This routing table have multiple route. Some protocol type is direct. Some protocol type is ISI. Some is local. Different routing table is populated from different routing information sources. So Junos routers stores all LAN IPs in the routing table. All destination network, all connected network will be installed in routing table. This is the normal behavior of the routing table. Junos routers contain two tables, routing table and forwarding. Routing table have all available path, but forwarding table have only base path. Routing table, all IP ranges learned from all BGP, OSPF, ISS protocols can be found here. IP ranges are also known as prefixes. So routing table will be populated from different routing information sources or different routing protocol. You can get one route from BGP, or you can get different or multiple route from your IGP. All are available, all route will be available in your routing table. The default routing table is iNetwork 0. That is for IPv4. You can also say it's the routing table for IPv4 unicast. Junos routers use the route preference of its protocol to determine which one wins. Every protocol use protocol preference. Protocol preference. Like see here, direct route, the preference is 0. Local preference is 0. ISS preference is 80. BGP preference is 170. Like this. So Every protocol use the preference value to compare other routing protocol, and lowest will be winner. Always lowest preference value will be winner for same destination prefixes. So this is the basically routing core concept. Routing core concept. Forwarding tables. This is the sample of forwarding table. Forwarding table also have destination prefixes, type, exit interface, next hop address. Okay, but this table have only paste. Advertising prefixes in an enterprise network. How you advertise your prefixes. See here, this is site A and this is site B. The prefix is, this is source prefix. You can say this is the destination prefix. So consider here, OSPF routing protocol is running here. So if you add this prefix in this router in OSPF routing domain, this prefix automatically advertise through this enterprise core to site B. Similarly, you can also add this prefix in site B router. This prefix automatically advertised through OSPF to another router. OSPF to another router. This is a normal advertising process. Service provider networks are different. Service provider networks are different. Multiple router is interconnected with each other. You can say site A, it's a customer, site B, it's a customer, and this portion is infrastructure. Or you can say it's a service provider core. Okay. And if you think enterprise, this is enterprise core. And you can say this is your branch, or you can say this is your customer. Service provider network, reason for logical separation. In service provider network, we need some logical separation. Okay. So why need logical separation? Prevents infrastructure prefixes from leaking to the internet. You want to prevent infrastructure prefixes, no need to advertise through the internet. Prevent rapid external changes from affecting their own internal infrastructure. Prevents customer and internet prefixes from overwhelming your network. The metrics used to select the best prefix are different for internal and external prefixes. Solution: combine BGP with either ISIS or OSP. ISIS or OSP. So in service provider network, say here, in this portion, we have to, or we should use BGP. Customer will connect with BGP, that means eBGP, and your organization router internally made IBGP. Then your traffic will be just getting prefix through BGP, eBGP, and advertised through BGP, and finally advertised to another site. That is very simple. That's why combine BGP with either ISIS or OSP. Consider BGP along with ISIS or OSP. That means as a ICP, you can choose OSP or ISIS. Over the ICP, you have to use, or you should use BGP. So ISIS or OSP is the topology. External BGP, that is external BGP, and service provider will be IBGP. So see here, service provider have multiple router. So there have some problem. Like this prefix, getting this prefix R1, through eBGP. Then R1 and R2, the BGP is IBGP. Automatically prefix is advertised to R2. But router 2 and router 3, this is again IBGP. So getting prefix from IBGP and want to advertise to again the IBGP peer. That is not possible. That's not possible. So we need full mesh. So full mesh have a solution, but it's a more configuration. It's a more configuration. It has more configuration. So what is the smart way or what is the smart solution? Smart solution will be route reflector. Consider a route reflector router. Just make IBGP session with route reflector in service provider core router and your problem will automatically solve. So eBGP, then IBGP, then eBGP. This is the design of service provider. So here we discuss routing and forwarding. That means service provider and enterprise core infrastructure. And now we participate some question and answer section after finishing this section. So why is logical separation important for external prefixes? To prevent the policy of prefixes from leaking to the outside world or internet. That is the one reason for external prefixes. External prefix means it can be getting from customer or it can be getting from artist. All are external prefixes. Okay. To prevent rapid external changes from affecting the internal infrastructure. So we should um, take extra care of external prefixes. If external prefixes any leaking, you will or your company will get trouble. Okay, so that is very important. Which protocols are called the link state protocol? We know it better. OSPF and ISIS is link state protocol. Simple question. What information is required by a router to forward a packet? That means just recalling the forwarding table. In forwarding table, prefix, next IP, and next of interface. These three information must have or required. Refresh, BGP next up. So BGP next up, it's a attribute of BGP. So it's a mandatory attribute. You know better. It's a mandatory attribute of BGP. So let's start. Forwarding hop by hop in a BGP network. Consider here. This is eBGP peer. BGP protocol next up R5. R5. That means this one R5 and physical next of R2. Physical next of R2. That means consider this prefix. Consider this prefix. This prefix coming from side B. eBGP, I'm getting this prefix with next of this interface IP address. This interface IP address. Advertising this prefix for IBGP. When I'm checking from this router, I'm getting the next stop is this one. But I'm getting prefix from this physical next stop or this physical path. So IBGP don't change next stop automatically, but eBGP can change next stop automatically. That is the reason. So you need some treatment. You need some treatment or you need some solution to overcome this issue or problem. So this is next stop problem, the BGP protocol next. So here is basically three things: learn via BGP, Router 5 is the BGP protocol next hop. R2 is the physical next hop. See here, see the route. This is the route. And next hop, this one, but protocol next hop is this. Protocol next hop is router 5, but physical next hop is router 2. So this is actually IBGP limitation. So let's the BGP physical next hop. Why was R2 the physical next hop? R5 loopback is learned by ISIS. R2 is the best next hop to R5. Therefore, R1 sent the packet to R2. That means your packet will be travel R1 to R2, then R3, R4, then R5, right? Like this. But your next hop will not change automatically. So you need some treatment. You need to add next hop solution. That means you need some policy to alter the next hop. We know it better. So for just tracing question and answer section, which command is used to show the destination prefix? Show route, then we'll set the destination prefix. Which protocol is used to advertise external prefixes? BGP. That means if you consider the internet, you can say is BGP. Only protocol is BGP. Okay, there is no alternative. So when you advertise some prefixes to another ASN or external organization, so that should be BGP. It can be upstream, it can be downstream. Okay, both are external. And the third section were just now in MPLS. Original historical motivation for MPLS. Why MPLS introduced? Some key terminology. The history of MPLS. Say, this next topic describes the historical challenge MPLS solved. But it is not the complete story. It skips our legacy technology like asynchronous transfer mode and frame relay. This technology is very popular before MPLS. Before MPLS, this technology was very popular for giving VPN traffic, for giving lease line, dedicated line, for everything. This technology is very big. But when MPLS just coming, in MPLS, there is there is a problem in ATM and frame relay. MPLS have solution of this. Like, so that's why MPLS is coming in front. They are a big part of the story of MPLS, but for now you can ignore them. Are you interested learning full story? No need to learn full story. You can learn from internet. Historical background basically not very much important. Modern routers route in hardware. You know about 9 lakhs prefixes. I'm saying IPv4. In IPv4, there it has around 9,000 prefixes. So default free zone, that means that is global table. Okay, that is global table. So no problem from many modern devices. Lookups happen instantly. That means if you consider 9 lakh routes, so you have to consider the router hardware. You have to consider every hardware don't support this. You need higher model hardware that will be support these prefixes or routes. Also have IPv6 prefixes. Okay, so If you consider higher model devices, it's very easy to handle. And if you think, just consider here, it's service provider infrastructure. This is the customer and this is the upstream. Okay. Consider here, uh, here is one router for connecting customer, another router for connecting upstream. In the middle, all infrastructure device is you just deploy the MPLS. They are just level switching from one point to another point. So no need to handle these prefixes, 9 lakh prefixes. So the disadvantage is the routing table or this prefix handling disadvantage is it's taking long time to forward packet. Takes long time. And if you just consider they have this router have multiple upstream. This is upstream 1 and this is upstream 2. Upstream 1 you are getting 9 lakh routes, 9, and another upstream you are getting 9 lakh routes. If BGP session down, this prefix is withdraw, but it takes time. But it takes more time. Okay. So in that case, if one upstream down, your customer automatically know this internet interruption. Okay. So this is you can consider your BGP session down or interruption, or you can consider route table lookup. So every point tell you that this takes long time. And if you deploy MPLS, MPLS will work with label, not routing table. And label switching is more faster than IP routing table lookup. So this is the main reason. The problem with old routers, early routers are very much slow. Switching in hardware, but routing in software. Every layer 3 lookup was punted to the CPU for processing. Very slow. But based on CPU, this device is now already market out or end of the market. Old routers could not look up IPs efficiently. The algorithm and process got slower as routing tables grew. More efficiency was needed. That means you need upper model or new hardware. Thousands of prefixes, 3 next stops. So example topology consideration. Label as a proposed lookup efficiency. They are just consider here. It's a P router, provider is router, and this another P router. They are just communicating one point to another point through level switching. So this level switching is more faster. Okay. So this is the advantage of MPLS. So now we will discuss MPLS label. MPLS label is just a number. MPLS label, just a number, just a numeric number. So see here the packet header, Ethernet header, that is after label, then IP header, TCP header, then payload. That means MPLS shrink between layer 2 and layer 3. You can say MPLS is 2.5. Layer 2, that means layer 2, layer 3 means layer 3. So you can say MPLS is 2.5. Label is inserted between Ethernet header and IP header. So this is the structure of MPLS header. MPLS label switch path and short LSP label switch path. So MPLS level, you can say it can be a level switch path. One, you can say it's a PE router, provider is router, and this is another PE router, provider is router. So when you consider another path here, like like this, like this, okay. So you can create multiple LSP over this physical path and over this physical. So for one customer, for you can say for one customer, you can say for um, traffic type, it can be IPv4 traffic, it can be IPv6 traffic, it can be voice, it can be data traffic. You can segregate and push your traffic or forward your traffic as per your designed LSP or configured LSP. So you have multiple options. It done depends on backend ICP or BGP. So LSP will added this advantage. This is MPLS basic function. So if you consider it's a ingress router just one label is inside, then you will get here one label, set one label, sending this label, this router 2, getting one label from router 1, that is incoming label, and this is a transit router. So transit router swap this label, like consider here, this label is getting from router 1. You can consider it's an incoming label, and when sending this label from router 2 to router 3, they are just assign another label and sending to router 3. This operation is called swapping, label swapping. So someone insert label or some device insert label, some device swapping label, just receiving incoming label and set outgoing label and send to another neighbor. Similar task is happened up to this one, and this is the pop router penultimate of popping. They are removing the label and sending normal IP packet to router 5. And router 5 will communicate with customer in normal IP routing protocol. So this is entire process level level switching entire process of MPLS. So there is three operation here. Three operation. One is ingress or push label. Number two is swap label. Number three is pop label. Pop means remove the label. So basically three functions. What are the advantages of modern routers over old routers? Modern routers, massive algorithm are used for performing lookups. That means saying the route table lookups. ASIC chips are used for forward traffic. This is more advantage. We are getting more faster forwarding in our modern router compared to old router because of ASIC chips and massive algorithm performing lookups. Which chip does the router contain to process, manipulate, and forward traffic in the network? ASICs. What are the advantages of creating pre-signal tunnels? Router can easily perform the lookups. Router can now look at the new header called labels. That means you can deploy MPLS in your network. Core routers can perform the next hop easily using the smaller label table. No need to maintain a huge number of labels. The label table is very small compared with IPv4 route table or IPv6 route table. This is the advantage. Modern use cases for MPLS, that is part one. Where we use MPLS. Improved hardware and improved routing lookups. Hardware improvement introduced line rate routing lookups, speed. This is basically hardware improved. If you consider just before 10 years ago, the router and interface capacity, and if you just think now, huge changes, huge changes. Before 10, we think 10 Gbps link. That is enough. That is enough. But now 100 Gbps, not enough. Need more than this. This is the improvement. So MPLS use cases, that is BGP free code. BGP free code. You can consider, you can free your BGP routing protocol. Talks BGP, ICP, MPLS, fast forwarding, large routing table. Talks only ICP and MPLS, very fast forwarding and small routing table. You just avoid BGP. No need BGP. Only configure ICP and MPLS. Your route table or your performance will be improved for considering forwarding. Talks BGP, ICP, and MPLS, fast forwarding, large routing table. Fast forwarding, large routing table. That means indicating the router. Indicating the router. This is P router. Provider is router. You need BGP. Yes, you need BGP. Otherwise, you cannot communicate with customer. This is normal IP routing protocol communication. This is your another location of customer. This portion have also the routing, that means BGP. That is external, not configure IBGP with customer or upstream. Okay, so you need this one. But inside this, router 2, 3, and 4, no need BGP. You no need BGP. So this is called the BGP free core. BGP free core. That means BGP free core means you don't have routing table here. Just they are blindly forwarding packet using the label. So your forwarding will be faster. So that is the consideration, or that is the advantage of MPLS. MPLS use cases traffic engine. So see here, there is multiple path here. We consider here failover. All device in a ring. If one device or one link goes down, another path will be automatically activated and forwarding traffic. So if we use both path, when both paths are live, when we utilize both paths, if we consider normal IGP routing or BGP routing, you can send traffic through one path. You can send traffic through one path because this is not the equal cost. This is unequal cost. Okay, if you consider IGP. So unequal cost, your traffic will, one path will be overutilized and another path will be underutilized. So if you want to utilize underutilized path, so you can use traffic engineering that is available in MPLS, not have in ICP. Okay, this is traffic engineering example. And another MPLS use case is PPM. Consider you have multiple customer. This is customer one site A. This is customer one site B. Another customer site A, another customer site B. See here, the IP prefixes, customer local IP prefixes is same. and demanding, customer demanding, um, they need logically separate routing table. They need logically separate routing table. So how it is possible? Normal ICP or BGP, that is not possible. If we consider, if we deploy MPLS here, we can configure MPLS L3 VPN. After that, we can give L3 VPN solution for these customers. That is easy for MPLS, but that is not easy for IP routing. That means you can say ICP or BGP. That is not possible. So MPLS and MPLS VPNs. The term MPLS has come to have two meanings. Generic meaning, everything you have learned so far using labels to forward traffic. Label is very important. But some engineers use the term MPLS to specifically mean MPLS VPN instead of an MPLS VPN circuit. Some people talk about their MPLS circuit. So someone say MPLS circuit, someone say MPLS VPN, but ultimately the thing is same. It's same technology, MPLS and MPLS. So this is some question and answer like this. What are the constraints that you can add to a traffic engineered LSP? Choosing the exact hop by hop path that an LSP takes. Tagging certain links should be avoided. Resignaling LSP automatically as new and better paths become available. Which hardware design is exceedingly popular in the service provider world? BGP free code. How is traffic engineering useful in MPLS? Traffic between two endpoints always takes the metrically best path. Modern use cases for MPLS, that is part 2. And part 2 will discuss MPLS use cases, IPv6 over an IPv4 core. You can travel IPv6 traffic over the IPv4 core. That is tunneling technology. That means tunneling technology. That is, see here, my router 1 can talk IPv4 and IPv6. Similarly, router 5 can talk IPv4 and IPv6. That is called dual stack. But enter between the router 2, router 3, and router 4. They have only IPv4 and talks MPLS. So you can send IPv6 traffic from router 1 to router 5 over the IPv4. It's possible. MPLS use cases, multicast. Multicast means point to multipoint, like point to multipoint. That is, consider here, this is the IPTV server. This is the IPTV server. You are sending streaming towards your customer. That is point to multipoint. Multiple receiver taking this service. It can be any streaming service. Example, IPTV. So multicast, that means multicast, that means you can get solution MVPN, multicast VPN, but also possible through MPLS. Which of this acts as a virtual switch between multiple sites that are all in the same broadcast domain? That is pseudoware or VPN. What are the benefits of IPv6 tunneling? Use BGP to address IPv6 between edge devices, offers IPv6 service without running them everywhere. No need to apply IPv6 in your all core node. No need. So this is basically introduction of MPLS. In summary, we discuss what is MPLS, so how it functions, and what is the advantage and what is the disadvantage. They're basically not any disadvantage like this. It all are advantages compared with compared with traditional IP routing table. Okay. So that's all for today, I think. If you have question, ask me. Any query or any question? Okay, so next we discussed in basically next class, MPLS the mechanics. So today I want to finish. Thank you very much for participating this class.